Hello everyone, and welcome to this mathematical presentation. Today we are going to explore a fascinating problem, finding the sum of alternating squares. The series is 1 to the 2 minus 2 to the 2 plus 3 to the 2 minus 4 to the 2 and so on, minus 1 to the m minus 1 multiply m2. At the first glance, this may look like a complicated alternating series, but as we will discover, it has a surprisingly elegant closed form. This is a classic problem that appears in many areas of mathematics, from number theory to mathematical competitions. Let's to solve it and find a pattern. The problem statement. Here we have the alternating square series. Sm equals to 1 to the 2 minus 2 to the 2 plus 3 to the 2 minus 4 to the 2 and so on, and minus 1 to the m minus 1 multiply m2. The problem statement find the closed form of this alternating series. This is the classic alternating series problem. Let's find a pattern. The compact form using the sigma notation, we can write the summation form Sm equals to sum k from 1 to m minus 1 to the k minus 1 multiply k2. M is a natural number. And expand form is Sm equals to 1 to the 2 minus 2 to the 2 plus 3 to the 2 minus 4 to the 2 and so on, and to us minus 1 to the m minus 1 multiply m2. The sign alternated each term. Here we investigate some numerical example. Compute the first few terms for m equals to 1. S1 equals to 1 to the 2 equals to 1. For m equals to 2. S2 equals to 1 to the 2 minus 2 to the 2 to the 2 equals to 1 minus 4 equals to minus 3. And for m equals to 2, 3, S3 equals to 1 to the 2 minus 2 to the 2 plus 3 to the 2 equals to 1 minus 4 plus 9 equals to 6. Also, here we have some more examples. For m equals to 4, S4 equals to 1 to the 2 minus 2 to the 2 plus 3 to the 2 minus 4 to the 2 equals to 1 minus 4 plus 9 minus 16 equals to minus 10. And for m equals to 5, S5 equals to 1 minus 4 plus 9 minus 16 plus 25 equals to 15. And for m equals to 6, S6 equals to 1 minus 4 plus 9 minus 16 plus 25 minus 36 equals to minus 21. Do you see the pattern in these examples? Try to recognize the pattern, observing the pattern value of Sm and for different value of m. For m equal to 1, from 1 to 6, we have different value of Sm, 1 minus 3, 6 minus 10, 15, and minus 21. So we can see the pattern, and we can write the pattern for Sm equals to minus 1 to the m minus 1 multiply m plus 1 over 2. The sign alternate and magnitude follow the triangular numbers. This is the important relation. So the main result, the closed form formulate Sm equals to minus 1 to the n minus 1 multiply n plus 1 over 2. So here we can verify in the formula n equals to 1, then Sm equals to minus 1 to the 0 multiply 1 multiply 2 over 2 equals to 1. For m equals to 2, the Sm equals to minus 3. And for m equals to 3, Sm equals to 6. After the comparison with the example in the progress slide, return verify the results. So we can go to prove the formula. Separate even and odd term. Case 1, m is even, so m equals to 2n. S2n equals to 1 to the 2 plus 3 to the 2, so on, plus 2n minus 1 to the 2, minus 2 to the 2 plus 4 to the 2 plus so on, plus 2n to the 2. Using known formula with formulas written, right? Sum k from 1 to n, 2k minus 1 to the 2 equals to n multiplied to n minus 1 multiplied to n plus 1 over 3. And also sum k from 1 to n, 2k to the 2 equals to 2n multiply n plus 1 multiply to n plus 1 over 3. These are a standard form of a square formula. So in part 12 proof, we can complete the proof for m equals to 2n for even number. S2n equals to n multiplied to n minus 1 multiplied to n plus 1 over 3 minus 2n multiplied n plus 1 multiplied to n plus 1 over 3 equals to n multiplied 2n multiplied 2n minus 1 minus 2 multiply n plus 1 over 3 equals to n to 2n plus 1 multiplied 2n minus 1 minus 2n minus 2 over 2 equals to n multiplied 2n plus 1 multiplied minus 2 over 3 equals to minus n multiplied 2n plus 1. Since m equals to 2n, we can write S2n equals to minus 2n multiplied 2n plus 1 over 2 equals to minus m multiplied m plus 1 over 2. And for odd case, for n equals to 2n plus 1, S2n plus 1 equals to S2n plus 2n plus 1 over to the 2. For problem from province slide, which have S2n equals to minus n multiply 2n plus 1. So we can write S2n plus 1 equals to minus n multiply 2n plus 1 plus 2n plus 1 to the 2 equals to 2n plus 1 multiply minus n plus 2n plus 1 equals to 2n plus 1 multiply n plus 1. And then since m equals to 2n plus 1, we can write S2n plus 1 equals to 2n plus 1 multiply 2n plus 2 over 2 equals to m multiply n plus 1 over 2. And finally, the unified formula combining both cases. So for even case m equals to 2n as m equals to minus m multiply n plus 1 over 2, and for odd case m equals to 2n plus 1 as m equals to plus m multiply n plus 1 over 2. So the unified form is m equals to minus 1 over minus 1 to the m minus 1 plus multiply n plus 1 over 2. And here we have the summary of the solution. Sm, the problem is Sm equals to 1 over to the 2 minus 2 to the 2 plus 3 to the 2 minus 4 to the 2 plus minus 1 to the m minus 1 multiply m2. And the closed form Sm equals to sum k from 1 to the m multiply minus 1 to the k minus 1 multiply k, and closed form Sm equals to minus 1 to the m minus 1 multiplied n plus 1 over 2. The different steps to prove the problem we have, we use the pattern recognition, separation of even and odd term, known sum of a square formulas and unification using the -1 today and -1. Thanks for watching. See you in next video.